anyways, it's really great to see everyone again. I hope your build weeks went well. I missed the presentations last night, but I'm sure they were amazing. Cool. Yeah, sure. I'd be happy to. Okay. Well, welcome to backend. Can you believe that you've made it this far? I'm actually really excited to teach you about backend. It's what I've spent the majority of my career doing, and it's what I enjoy doing the most. React is fun, front end is fun, but for me, I prefer backend. I don't know about you, but it's actually, it's more of like an engineering or a technical mindset. So versus front end, which is more of like a creative mindset. When we work in backend, you no longer have to worry about like styling or UIs or any of that, right? In backend, our UI is just like JSON data, right? It's just working with data versus working with actual user interfaces and stylings, things like that. So it's a lot more technical. It's a lot more like, takes more of an engineering mindset versus a creative mindset. So I don't know if that's good or bad, but might just depend on what you prefer. I'm actually curious, how many of you feel like you lean more towards the creative side, and how many of you feel like you lean more towards the engineering side? I'll put up a poll. It'll be interesting to see which ones you prefer. Oh, I haven't used Poly in a long time. So you feel like both, definitely in the middle. Yeah, I mean, although you're being trained as full stack developers, unless you get a job at a really, really small startup, chances are you're going to be more than likely going to be specializing in either back end or front end. They're usually separate teams, depending on where you end up working at. So it will help to know which one you prefer. So something to think about as we move along. Who knows, maybe you think you prefer front end and we'll start to get into back end and you'll find out that you actually really like it. You never know, you might surprise yourself. With that being said, I want to emphasize that we're really only skimming the surface of backend in Lambda School in this block. Since it's much more technical than front end, the rabbit holes go a lot deeper. So we don't have nearly enough time to go as into depth with it as we did with front end. So if you do lean more towards the technical aspect, towards the engineering aspect of development, if you lean more towards backend, it's going to take a lot of extra effort beyond what we actually teach you at Lambda to become proficient and get a job as a backend developer. You'll kind of have to maybe you'll have to get a job as a front end developer first and kind of work your way to the backend. Just because there's so much more to learn and there's so much more to specialize in when it comes to backend. You might have to learn a few new languages, right? Things like Python or Go or Ruby or C#, unless you get a job as a Node developer, which Isn't always the case. You might have to learn some like network or systems engineering or DevOps. You'll get a lot deeper into computer science principles, things like algorithms, data structures. But hopefully this block will give you a solid introduction to backend and give you a feel for what it's like to be a backend engineer. Okay, so you might surprise yourself. You might find out that you really like it and you want to delve into it even deeper from where we leave off, or you might decide you hate it and you want to be a front-end developer. So, with that being said, let's get started. Which is easier to get hired? Honestly, it's probably easier to get hired as a front-end developer, but it's easier to keep a job as a back-end developer. I would say back-end developers are a little bit more valuable in the field because their skills take a little bit longer to develop. It's a little harder to find a good back-end developer than it is to find a good front-end developer. So yeah, I mean, it would depend on where you're working, but I would say back-end probably has a little bit more job security. So we keep throwing around these terms, right? Front end and the back end. We know what the front end is. Hopefully, you know, it's HTML, CSS, and JavaScript code that we can just run in our browser to display some kind of a user interface, right? But what is the back end? When we say back end, what comes to your mind? How would you explain back end? Servers, logic, API, networks, storing, moving, and delivering information, framework for delivering data. Yeah, these are all right answers. Essentially, a backend is just a computer program, right? Or a collection of computer programs, usually without a user interface that's set up to accomplish a myriad of different tasks, right? It could be anything. Something maybe like responding to HTTP requests, right? Running as a web server. Or maybe automatically sending out emails at a certain time every day, right? Or maybe scanning a system for security issues or writing logs to a file system. Maybe connecting a video or converting a video or an audio file, right? That could be a backend task. Or training an AI system, right? You could go really deep into this. A backend is just a computer program that runs outside of the context of a browser, right? You don't need a browser to run a backend. It's just a computer program. It can run on anywhere on any device, right? No browser needed. Unlike our React apps, unlike the front end, which actually requires a browser to run, right? So when we talk about backend, it's kind of this broad term. It can be thought of as pretty much any computer program that's running outside of the browser that your browser website depends on in some way. So traditionally, these programs were written in languages like C and C++, right? Java, Ruby, PHP. These languages that front-end developers didn't traditionally know, right? You couldn't write this stuff in JavaScript because JavaScript only ran in browsers and it didn't have access to low-level things like the file system, right? Low-level things that you need in order to write these back-end systems. So this is where Node.js comes into play. Okay, so Node.js is what we're going to be working in throughout this entire block. The short version of what Node.js is, how it came about. Essentially in 2009, this guy named Ryan Dahl, he extracted the JavaScript engine from Chrome, from Google Chrome. He took that JavaScript engine, he pulled it out, and he made it available as a standalone runtime environment. Okay, so that we could run JavaScript code on a computer without running it through the browser. So that's what Node is. That's all it is. It's a runtime environment that lets us run JavaScript code without a browser. Okay, and this opened up that entire world of native applications and backend applications. It opened that entire world to JavaScript developers for the first time. Okay, so that's what we're going to be working in, this runtime environment that allows us to run JavaScript code without a browser. That's Node. So let's take a look at it. So if you should already have Node installed. We've used Node quite a bit before, actually, even if you didn't know that you were using Node. When you type like npm in your console, that's actually using the Node package manager, which runs on Node, right? You can use npm without a browser because it's built in Node. So you should already have Node installed. If you needed to like upgrade it or downgrade it or whatever, you should have the correct version installed, somewhere between version 10 and 12, preferably. But once you have it installed and you're in your terminal, you can just type node and then hit enter. And it puts us into this REPL for Node. So we can now just type node code, type JavaScript code, and it will execute similar to how it would execute inside of the browser's console, right? So we can say console log hello, right? And it's gonna log out hello. You could say 1 + 1 = 2. Right, you can now write JavaScript and it's going to execute in this runtime environment without the browser. And since this is native to our computer, right, this is just running natively, we can access low-level things like maybe the file system, for example. Let's say we wanted to write a program that created a whole bunch of files on our file system just instantaneously without having to go and create, like, say we wanted to create like 100 different files. Right, we could go through and do that manually for every single file. But now that we can run JavaScript natively on our systems, we could just write a JavaScript program that does that for us, right? It kind of opens up this world of low-level programs and scripting to JavaScript. So let's look at what this actually means. An example of what we could build with this. So not only can we just run the Node REPL just by running Node, but we can actually run files, just JavaScript files using that Node runtime. So if we, let's create a new folder. You can just say make dir and let's call it intro to Node. And then go into that folder, cd intro to Node. And then let's create a file called index.js, just an index.js file. So if you're in the command line, you can say touch index.js, or if you're in your code editor, you can create a new file that way. And then you can open up that folder in your code editor. By the way, if you don't have a shortcut in your command line so that you can just type a command and it opens it in your code editor, the current folder, you should definitely install that. For Sublime, it's subl dot, and that'll open the current folder in Sublime. If you're using VS Code, I believe it's just code dot, and that'll open this current folder in VS Code. If you don't have that installed, I think in VS Code, you just type Command-Shift-P and maybe like type command. There should be something that says install command line tools or whatever. Sublime comes with it already installed, I believe. Oh, I thought I was going to show you in VS Code. I actually don't have VS Code installed at the moment. But if you just type Command-Shift-P, and then it should come up in there, just install command line tools. And then once you have that installed, you can just go into your folder and you can type code dot and then hit enter, and it'll open it up in VS Code. Yes, it was in the training kit video. I think it was the first video. So let's write our first Node program. Let's write a program that will create a folder in this folder. So it'll create a subfolder. And inside of that subfolder, let's create 100 different text files that just have some text inside of them, maybe just numbered like 1 to 100.txt. Okay, in a practical world example, if you were tasked to maybe by your manager to create 100 different text files, yeah, you could go create each one individually, right? And do that manually, but now that you know how to code, you can go automate this process with a Node script. So let's do that as our first Node program. Go into your index.js. And the first thing we're gonna write is we're gonna write const. We're gonna create a constant variable. We're gonna say fs equals require fs. Okay, so there's a few things going on here. So first, notice how we're using require instead of import. So in our React code, we've been using import, right? We would say import.fs from fs, right? But in this case, since we're now running in Node, we actually don't have to transpile our code like we did with our front-end apps, right? Our code doesn't have to be, it doesn't have to run in the browser. It just has to run with Node. And Node supports much newer JavaScript than the browser does. So we don't actually have to transpile this. So we can use this require syntax just natively without having to transpile it. Unfortunately, the import syntax is still in the experimental stage in Node, so it's not officially supported yet. So for now, maybe in the future we can write it like this, but for now we're just going to type require, and that's going to pull in this dependency called fs. Okay. Notice how there's no file called fs.js, right? And we don't have a package.json that installs fs. That's kind of just this weird dependency that's coming from somewhere, right? We're importing this dependency, but we don't really know where it's coming from. Does anybody know where that dependency is coming from? Any ideas? Somewhere in Node modules, but we don't have a Node modules folder. Yep, you got it. Aislinn, Steven. It's coming from Node itself. Okay, Node, the Node runtime, it comes with kind of a standard library, similar to a lot of different languages. A lot of languages come with standard libraries that have just built-in functionality for common things like writing to a file system. Node comes with all these pre-written libraries that we can just require, and it just brings it in for us. It's automatically included with the Node runtime. It's built in. Right, and there's a bunch of different libraries that we can use that Node comes with. If you ever want to read through all of them and see all the cool things you can do with Node without having to install any third-party dependencies. And this package, fs, is one of them. Okay, it stands for file system. This package is going to allow us to actually work with our local file system, create files, delete files, create folders, so on and so forth. So now we've imported fs. We can now use that dependency. Okay. So the first thing we're going to do is we're going to create a folder. Right? We need to create some kind of a folder right next to our index.js that contains, that will contain all of our text files. So let's give it a name. Let's actually name the folder date.now. The folder name is going to be the current timestamp. Okay, and then we're going to call fs. We're going to call it file system module dot mkdir, make dir, sync. And that's going to be a function that's exposed to us that we call, and then we can just pass through dir. We also have to convert dir to a string, because that function expects a string. And that's it. Okay, now if we run this Node program, it's going to create a folder with the current timestamp as the name. Now we can take this one step further, and let's go into that folder and create maybe 100 text files that are all numbered and have some content. Okay, so how do you think we would do that with just plain old JavaScript? What's something that we can do to iterate over something a certain number of times? What's the syntax that we would use? A for loop, right? Good, Cliff. Let's just write a for loop. We can write for let I, let's maybe start at 1, right? Maybe we can go until 100, so we can say I is less than or equal to 100, and then I plus plus. All right, so we're just gonna iterate over this code inside of our for loop 100 times. And then there's another function we can call from that file system module called write file. So we can say fs.writeFile sync. And this is going to take 2 parameters. It's going to take the file name, and it's going to take the file contents. So for the name, let's put it inside of our directory. So we can say dir slash, and then whatever index we're currently on. We can say i.txt. It's going to be the file name. And then the content, maybe we can just say hello from index, whatever the index is. And that is it. You have now written your very first Node program. In 8 lines of code, we've accomplished something that could have potentially taken an hour of manual labor. Right? We've automated something with a very simple script that makes our life, that could potentially make our lives easier. This is a simple example, but the concepts are applicable to many other things. So now if we go, let's go back into our terminal, and let's just execute this file. All you have to do to execute it is just type node and then give it the file name, index.js, and run it. And boom, it's done. It ran very quickly. If you look in your folder, it created a folder with the current timestamp, and it created files 1 to 100. Right, and inside of each one, we have hello from index, whatever the current index was when it was created. Awesome, right? So now if you're at some job and your boss asks you to do a monotonous task, and you can just write a script to automate it and then just chill for the next 55 minutes. And since this is just a native program, we could make it do anything we want to, right? We can make network requests, we can write to the file system, we can read from the file system, we can pull in external dependencies, we can do anything we want. It's very, very flexible. Okay, the command to execute was just node index.js. That's it. Yeah. All right, so what's the difference between import and require? Require is just an older import syntax. Okay, the import syntax is newer. Not yet supported in Node. And since we're not using Babel or create React app or anything like that to transpile this code, we don't use that newer syntax. We just use the older syntax that just works natively with Node. Yep, so FS is a native module that Node gives us that allows us to work with the local file system. This is something that we couldn't do just running JavaScript in the browser, right? Because the browser is kind of sandboxed to its own environment. Code running in your browser can't write to your file system because it sits in that secure sandbox. If code in the browser could write to your file system, that would be a huge security hassle, because if you went to some bad website, right, they could install a virus on your computer and you wouldn't even know about it. So browser code runs kind of in its own sandbox in isolation from the rest of your computer. But this code runs natively on your computer so that we can work with the file system and work with all of those native things. So, like everything else in the development world, there are pros and cons to using Node. Right? Obviously, this is very cool. This is very easy to write quick programs to get things up and running very quickly, to automate things with scripts, right? It's just very easy to write and get going. But there are pros and cons. Okay, let's talk about those real quick. So the pros, obviously, it's easy to write. It's easy to get something up and running quickly. You no longer have to learn multiple languages to be a full stack developer, right? It's because of Node that you can come to Lambda school and be a full stack developer while only learning JavaScript, right? You don't have to go learn Java or C++ or some other obscure language. You just know JavaScript and you can be a full stack developer. So that's pretty cool. Another pro is we can share code between our front end and back end, right? Since our back end is now JavaScript and our React app is JavaScript, maybe we write some code that applies to both ends and we can reuse that code, maybe like through an NPM module, right? That's another huge plus is we have NPM packages. NPM is full of a lot of really great packages that take a lot of the work out of our hands, right? Makes life easier for us as developers. Most of those great NPM packages that we've used in our React apps on the front end, those can also be used on the back end, okay? So cons, most NPM packages can be used in the back end too. I would also consider that a con because not all NPM packages are, you've probably found this to be true, but not all NPM packages are the highest of quality. And it's a much bigger deal to have bugs or vulnerabilities in your back end than it is to have vulnerabilities on your front end. All right, so when you're using like NPM modules, you have to be very careful as to what you install because your back end is a lot more sensitive, right? A bug in your back end could lead to data loss. It could lead to hackers getting into your database and exposing like email addresses or passwords, things like that. So you got to be careful when you're dealing with backends. Another downside is JavaScript is single-threaded, okay? Which means if your computer has more than one processor, if your processor has more than one core, so say you have like a 4-core processor or a 6-core processor or a dual-core processor, JavaScript can only run on one of those, okay? So running Node code does not utilize all of your processor power versus other languages which can utilize all of those cores. Okay, so JavaScript is single-threaded. So because of that, sometimes these Node programs can run a lot slower than programs that are written in other languages, right? So if you're writing something that's very dependent on performance and speed, maybe Node's not the best option, right? A lot of times Node is chosen for convenience, right? Or maybe cheaper development costs. You can see how quickly we are able to write a program and get started. Right? Even when it's not the best tool for the job. A lot of times it's chosen when it's not the best tool for the job. And it's important to use the right tool for the job in coding, or you'll quickly run into issues with scaling, debugging, deployments, feature sets, things like that. So Node is very good at quick prototyping, web servers, things like that, but it's not always the best tool for everything. So it's good to keep that in mind. It's not just a fix-all for all backend stuff. It may still be worth it to learn other languages to implement things. But it's cool that we don't have to learn a new language to actually write backend code. So what's a case when Node would not be a good choice? Say you're starting a company, right? And you're building out your engineering team. You're deciding on a tech stack. What's an instance when Node would be a bad choice, a bad technology choice, based on the pros and cons that we just listed? Danny. No, Node is not the best. It's good for a lot of things, but not everything. Yeah, maybe you need something that's really graphics intensive, maybe a game, right? Or processing images and videos, a streaming service, like things that need a lot of performance, right? Maybe like an iPhone app. You can actually build iPhone apps and iPad apps with JavaScript, but sometimes it's not always the best choice, right? Maybe you need a lot of performance. Maybe it's very graphics intensive and it would be better to use the language that's native to the platform, right? Maybe it'd be better to use Swift or Go or some other language that's a little bit more performant. What's a case when Node would be a good choice? What kind of things do we want to use Node for? Front-end apps, right? What about maybe web servers, APIs? Good. Let's for now, let's say web servers. Web servers are a good choice to use Node, specifically for our purposes right now. So what is a web server? Venki, you beat me to it. What is a web server? If we go to, let's go to lambdaschool.com. Okay, we know that our browser just made a GET request to the servers that are behind lambdaschool.com's IP address, right? Our browser made a GET request to that web server, whatever that is. But what is that web server? Like, it's a computer, we know that. Good, yeah, a web server is literally just a program. It's a computer program that's running on that computer, whose sole purpose, the sole purpose of that program is to take in HTTP requests, to take these incoming requests, and to build some kind of a response and send that response back to the client. Okay, that's the web server's sole purpose. So it receives a request and it gives a response. That's what a web server is. So anytime you go to a domain, right, anytime you go into your browser and you type in a website, at the far end, there's some web server somewhere that's actually built, that's receiving that request and that's building a response that you eventually see in your browser. So it's software that's specialized for that one purpose. So maybe the response is HTML, right? In this case, when we go to lambdaschool.com, that response from the web server is going to be HTML. But maybe we're building an API, right? And our web server is running an API. What would our response be if it's an API? If our web server is running as an API versus an actual website? Depends on the request. Some kind of data. Yeah, it's going to be some kind of data, right? Usually like JSON data. If you use the internet prior to like 2010, maybe not, maybe even earlier, it would have been XML data, right? Some kind of data object that doesn't look super useful to humans, but computers are able to translate that into actual useful information. Cool. So let's build a basic web server in Node, something that can take in these requests and respond with some kind of data, some kind of a response. Before we jump into this new code, are there any questions so far? Can we explain the difference between JavaScript that runs on the browser and JavaScript that runs on the Node.js environment? So there is no difference really. They're both just JavaScript, right? JavaScript is just a language that can run in Node or in the browser. There are some minute differences that we should talk about though. Maybe if you think about JavaScript running within the context of the browser, we have like APIs that we use quite often that might not be available in Node. What are some things that you can think of that might not be available in Node, in the Node version of JavaScript, but it is available in the browser version of JavaScript? Is there anything that you can think of that might be available in the browser but not in Node? The window, right? Maybe that alert, when you call alert in the browser, it's going to pop up with that alert box, right? Node doesn't have that, since Node doesn't run in the browser, so you can't call alert in Node. Anything that has to do with the DOM, right? Obviously, there's no DOM when there's no browser. So there's differences in the functions and the APIs that we can use, but it's still just JavaScript. It's still just the JavaScript language. So anything that's not specific to the browser, to that window object, we can use in Node. And no event handlers, right, in Node, because there's no user interaction. There's no user interface. Okay. Nick, looking through the API docs, is there an FS command to remove, delete a directory? Yep, it's called unlink. The term for deleting a file or a directory in Node is called unlink. All right, let's build a basic web server. It's actually really easy. And then we'll take a quick 5-minute break. Let me paste this code into Slack if you need it, if you can't get it to run. You also don't have to follow along with that if you don't want. That was more just for demonstration purposes. A real world example of as to how Node could be useful outside of the context of web servers. So let's create a new file. It's in that same folder. Create a new file and let's call it server.js. This is going to be our web server. So the first thing, let's import a dependency from that Node standard library. If you go look at that link, there's actually a library called HTTP that we can import that makes it really easy to create a web server. So let's import a module called HTTP. So we're going to say const HTTP equals require HTTP. Either or, event key, library modules, probably in this case modules. Just call them third-party dependencies. That's a catch-all for any third-party dependencies. It is different based on the language though. I think it's modules in Node. I think in like C++ and Go, it's packages. In Python, it's packages, I think. I'm not sure there. Okay, and then we're just going to create another variable and we're going to call it server. We're going to say const server equals http dot create server. Very complicated, I know. Create server is going to be a function that we call. And then when we call that function, we're going to pass a callback as the first parameter, as the only parameter. So what this is going to do is when our web server is running and someone comes to our website, to our URL, it's going to run this callback for every single visitor to our site. Okay. Yes, it's always a callback, Danielle. When we're creating a raw HTTP server, we pass a callback. And this callback is going to have two parameters. The first one is going to be REQ, short for request. And the second one is going to be response. The homies, right? That's what Luis calls them. He calls them that because you'll always see these two parameters together. When you see the request parameter, it's usually followed by the response parameter in these callback functions. And most of the time, you'll see them shortened to just REQ and RES for request and response. So this function, it's going to run every single time someone comes to our website, anytime we get an incoming request. So there's a few things we can do inside of this function to build the response and send it back to the user. Okay, so first of all, these two parameters, they're kind of meant for different things. This REQ parameter, the request parameter, it essentially allows us to access information about the request. Okay, we can get request headers. We can get the requester's IP address, things like that. All right, we can get information about that request, maybe some data if it's a post request, right? We can get that payload data. And then RES, the response parameter, we can use to build that response for the user, right? We can give it a status code. We can give it some response headers. We can actually trigger the response to get sent back to the client, right? We can trigger the response to be complete. So if we want, let's use both of these. First of all, let's use the request parameter and let's just log out the user's IP address. So when someone comes to our website, it's going to log out their IP address to our console. So we can just say console log IP for IP address, and then we'll just say req.connection.remote address. And that's going to log out the user's IP address when they come to our website. Now let's build a response. So we can use that RES parameter to build our response. We can say RES dot, so maybe set a status code, set the status code to 200, right, since this is going to be a successful response. Maybe we want to set some response headers. Maybe we want to set the content type, right? We can say res.setHeader. We're going to set the content type. Let's return some HTML. So we'll say content type text/HTML. And then let's write some actual information to the body. Let's respond with some actual content. So we can say res.write. And we can pass in a string that's going to get written as the response body. So we can write some HTML in here now. Say HTML, body, maybe just do it like an H1 tag that says, hello world. All right, so it's just a basic HTML site. It's going to write that as the body. And then we just need to close the response. We need to trigger to Node. We need to signal to Node that this response is done, send it back to the user, to the client. We can just say res.end. So now anytime someone comes to our website, anytime any visitor comes to our site, it's going to run this function for them specifically. It's going to log their IP address out, and then it's going to set the status code to 200 and return some HTML. Now let's start the server. So we've built the server, it's ready to go, but we still need to start it. We need to run it, right? Make it so it listens for incoming requests. So let's say server.listen. It's another function that's provided to us. And then we're going to give it a port and a host name. So let's store those in variables. Let's say const port. Let's run it on port 8080, okay? Or whatever you want. And then let's say const host for the host name, and let's run it on 127.0.0.1. Which is just another way to say localhost. And then our listen command is going to take the port, and it's going to take the host, and then it's going to take a callback that will run once it starts, once it successfully starts. So inside of that callback, we can just say console log server running at, and then maybe give it the address. So make this a template literal. We can say running at http // and then give it the host, colon, and give it the port, so that we know when we run the program, we know where it's running so that we can open it in our browser. And that is it. We have now built a web server in Node. That's literally all it takes. Okay, so if we now go into our terminal and type node server.js, you should see the message server running at 127.0.0.1 port 8080. Let's try it. Let's go in here and we'll type node server.js. So notice when we run this, the program, it kind of hangs. Right? It doesn't ever close automatically. It doesn't stop running. That's because it's waiting for incoming connections, right? This is now a web server that's running and it's waiting for those incoming connections. So it's never going to close automatically. If it closed automatically, then our website would go down, right? We want it constantly listening for these new connections. If you want to stop it, you can just hit Control C, and that will stop the script from running. But if you don't hit Control C or it doesn't crash, then it will continuously run forever. Okay, let's try and go to that URL. So we see we're now running at 127.0.0.1 port 8080. Let's go to that in our browser and see what happens. Look at that. We now have a web server that's serving this really basic HTML page. Hello world. If we look at the headers, the response headers, you'll see we have the content type that we set, the text/HTML. We have the status code of 200. Essentially that response that we built with Node is being interpreted correctly by the browser. That's all it takes. All right, so let's talk about the host name real quick. So Venki, is the host name always the same for all browsers? The host name doesn't have anything to do with browsers. Okay, the host name has to do with your network, with your local network. If you're running a website locally on your machine, it has to run on your local network. Okay, so it either has to be localhost or 0.0.0.0 or 127.0.0.1. Those are just the addresses that are predefined by your machine as your local network, right? So that you can go to the URL in your browser. If you were running this live on the internet, let's say you had your DNS records for jasonmaurer.com pointing to this web server, then you would change your host to jasonmaurer.com, right? If I were to just change this to jasonmaurer.com right now and run it, it wouldn't actually work because my browser wouldn't know that jasonmaurer.com should point to my local machine. right? But it does know that 127.0.0.1 and localhost, it knows that that those should point to my local machine, which is why we use those when developing locally. Even a lot of times when you deploy your application to a hosting service, say you deploy this to Zeit, it's still probably going to run on the local host because Zeit puts other things in front of it that allows it to run on localhost. But if you were to just run this just raw on your own server, you could change your host to whatever your domain name is. Okay, let's talk about ports. So someone asked, can we explain a bit about the ports? I didn't realize there were so many, and how do you find them? Are certain ports reserved for specific tasks? Yes, that's actually a really good question. So ports are just, essentially they go along with an address for a network, right? So if you're requesting something at a certain port, there can only be one service running at that address and at that port. So when we run this Node program on our computers and it runs on port 8080, that's the only thing that can be running on our computer at that port at that time, right? If something else tries to run on that same port, you're going to get an error. So there are certain ports that are reserved for certain things. If you just go to your browser and you type an address and you just go to like lambdaschool.com, if it's using HTTPS, that means it's using port 443. Okay, if it's using just HTTP, that means it's using port 80. So those are both reserved for HTTP traffic for that protocol. If you use like maybe port 22 is reserved for SSH traffic. There are a lot of reserved ports, but usually ports that are above, I think 3,000, like above 3,000 and below like 65,000 are not reserved for anything. They're just open to do whatever you want on. So you can run a web server, you can run some kind of a network service or whatever you want. They just ensure that you can run multiple services on one host and they don't clash, right? They can run on different ports. I hope that makes sense, whoever asked that. If you have any follow-up questions with that, let me know. If you were to host an API on Zeit, would you need to make it port 80 so you don't have to put the colons after the domain name? Yes. So if you're hosting like on a managed service, a lot of times they'll give you a port to use that you have to specifically use in your code, or you just run it on port 80 so that you don't have to actually type in the port when you go to the address in your browser. If there's no port, if we just leave the port out, our browser assumes that it's port 80. Unless it's HTTPS, in which case our browser assumes that it's port 443. All right. We just covered a lot of stuff. So let's take a break. I'll leave both of these open. Let's see, rows 2. No, that's not what I wanted to do. Okay, 5 minutes. I will see you then. All right, come on back. So someone asked, there was an announcement, alert in the announcements thread saying that you're going to have pre-recorded lectures on Thursday and Monday. That does not apply to us. Okay, we're going to have a lecture as normal on those days. Since I'm a contractor, I'm not a full-time employee of Lambda. I don't participate in their cool stuff. I'm an outcast. All right, how are we feeling so far? I'm going to rename this index.js to something. I'm going to rename it to file create, just so that we're not confused as to what it's doing. All right. Man, I don't know why my video feed lags so bad on my end. You're not getting any lag on your end, are you? It's like super delayed. Strange. Okay. If it's good on your end, then it's fine with me. Yeah, I don't know. That delays it. All right, cool. Make sure you update the live poll in Slido as to how you're feeling based on what we've covered so far, just a 1 to 5 star rating. We're at an average of 3.2 right now, which is pretty solid. All right, so we've now built our first web server with Node. Notice how when we log out the IP address, so we're logging out IP, right? Let me start that server again. Notice how when we go to the URL, right, we go to our web server, it's on port 8080, and we log that IP address out. It's not logging in the browser console, right? It's not logging here. We don't see our IP address here. It's actually logging in our console, in our terminal console, right? Our IP address of 127.0.0.1 because that's we're visiting our site from our local host. So now that we're running Node in, we're running JavaScript in Node and we console log, it's not going to log to the browser. It's going to log to the environment that it's running in, which is in this case Node, right? Just native on our machines. Our browser actually has no idea that our server is running Node, right? When we go to our website in our browser, it has no idea that it's running JavaScript in the backend. It could be built in C++ for all of it knows, right? As long as it gets a proper response to its HTTP request, it doesn't care what the server is actually running. So this server that's running, it really has nothing to do with our browser. Any code that we write in here is not going to run in our browser. Unless I guess you could argue you could write like JavaScript inside of your HTML response, but that's different than what we're talking about. Yeah, you can trace Russian hackers now. So now if you launch this website and you look at your logs, you'll see the IP address of every single person that comes to your website. And then you can do an IP trace and figure out where they live. It'd be super creepy. It's fun stuff. So this is it's a super simple example of a web server. Obviously, it's not very practical, right? We still need things like routing, data parsing. There's a lot of things that we would still need in order to make this a functional API. Right now, we could write all of that stuff from scratch. We could write like a router from scratch, JSON parsers from scratch, all of that stuff. But for our purposes, it's going to take way too much time. We don't want to write all of that from scratch. So instead of doing that, we can install an NPM library to help us with this called Express. So Express is just a framework. Let me share a link with you really quick. Express.js is just a framework that sits on top of this HTTP module that we just used. It sits on top of that, and it gives us a lot of functionality out of the box that we need to build a functional API. It's kind of like how React helps us with the DOM, right? React is a framework that sits on top of the DOM. It helps us communicate with the DOM. It makes things a lot easier. Express is kind of like React for the backend. Right? It allows us to work with the HTTP protocol, building responses, sending responses, all of that stuff. It makes it a million times easier than just doing it manually. Okay, so Express, it comes with a router. It comes with support for middleware, which we're going to get more into depth with next week. It comes with a lot of helper functions. Just makes our lives as API developers a lot easier. So let's install Express and convert our server, our raw HTTP server, let's convert that over to use Express instead of what it currently is. So first things first, if we need to install NPM dependencies, what do we need to do? We need to npm init, right? We need to create a package.json so that we can have a list of our dependencies. So let's type npm init. You can answer all the questions, package name, version. I usually just leave most of this stuff blank. The entry point actually is going to be server.js, not file create. So the entry point is going to be server.js. Blank, 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 blank. Okay, yes. If you don't want to answer all those questions, you can just type npm init -y. That'll just answer yes to all the questions. But that should create a package.json for us. So now we have this package.json. It's just empty. It doesn't have any dependencies in it. It created a start command for us, so now we can run npm start instead of running node server. Okay, so we have a package.json. Now we can install Express. So let's just npm install Express. And Express is now installed. Okay, so now that it's installed, you see we have a node modules folder now that has all of these dependencies that Express brought in, and we have Express, right? We have that dependency. We can now require it into our code, just like we did when we installed stuff in our React app. I'm gonna comment all of this out for now. Now we can say const express equals require express. Yep, npm install now defaults to --save. So you don't have to say --save anymore. They install Express. You can still say it if you want, just for just to be safe, but you don't have to. So let's import Express, require Express. We've now imported it. It's pretty much the same stuff as below, except we can cut out a lot of the boilerplate code that we had. So first things first, we have to kind of create an instance of Express. We have to create like an app instance. That's just the way that Express works. So in order to do that, we're going to assign it to a variable called app. We're going to say const app equals and just call Express as a function. And that essentially creates an instance of our Express app. And now that we have that instance, we can add routes, we can add helper functions, we can add middleware, and we can start it on a certain port and host, just like we did before. So let's actually reuse that code that we used to start. So we had that server.listen with the port and the host. We can uncomment that and reuse that. I don't want to uncomment that. So instead of saying server.listen, we can now just say app.listen to start our Express app instead of just a raw HTTP server. Okay, and just save that. Save that as it is, comment out your handler function, and just run it as it is and see what happens. I'll make my terminal window really tiny. So now we can run node. Actually, we don't even need to run node. Now we can just run npm start since we have that start script, right? And that's going to start our server just like it did before, except this is an Express app versus just a raw HTTP server. If we go to the URL, we should see cannot get root because we haven't defined a route yet. We haven't defined a handler function. But our server is still running, right? It's responding with a 404. We just need to define some routes now. And Express makes that really, really easy. We can just say app.get. So this is going to define a route for a GET request, right? We're going to give it a route as the first parameter, just a string. So we're going to define a route for the root path. And then it's going to take that same request and response callback function, the homies, right? And then inside of here, we can kind of do the same thing that we did below, but we don't have to set the status code. We don't have to set the header. We don't have to specifically write and then end, right? We can just say res.send and then give it our HTML string. And then we can still log our IP address if we want to do that. So let's copy that line. Express even makes our IP address a little bit more accessible. Instead of saying connection.remote address, we can just say req.ip. And save that. Restart your server by just Control-C and then rerun the command. And now if you go back to that URL, you should see our HTML, our hello world. So it's not totally obvious quite yet how this helps us. But let's show you another example route that we could utilize some of Express's methods. So let's define another route. All we have to do is just say app.get again. We can call app.get as many times as we want to define as many routes as we want. We can do app.get. We can call app.put for a put request, or .post for a post request, or .delete for a delete request. You'll see that a little bit later. But for now, let's create another GET request. And this time, let's do /lambda. So we're going to create a GET request for the route of lambda. It's going to be our same callback function with a request and a response. Only this time, we're going to do something kind of cool. We're going to redirect the browser to lambdaschool.com. So normally if this was just a raw HTTP server, we'd have to build like the headers and set the location header to whatever the response is and set the response code to 301 and kind of build that redirect manually. But since we're using Express, we can just call res.redirect. Then we can give it a URL. Let's redirect to https lambdaschool.com. And we no longer need all of this stuff. Okay, so now if you stop the server and restart it, anytime you make a change, you have to restart the server and try going to our URL /lambda, and it will now redirect to lambdaschool.com. Pretty cool. Let me go back to where we were at before. All right, so this is where we define our route along with a handler. And we can add additional routes by calling app.get as many times as we want. Security prevented a redirect. It's some tight security if it's not letting your pages redirect. Adam's issue, e-lifecycle. Might just have to Google that one, see if you can try and figure out what that error code means. Let me post the code that we have so far. See if you have any typos. So we've now converted our raw HTTP server to an Express server. Right? We now have a lot more flexibility in terms of the features we can build with our API. So right now our root route, it's just returning some HTML. It's kind of interesting because this is how sites were made back in the day, like back before all of these JavaScript frameworks took over everything. Right, back in the day before JavaScript frameworks, when you wanted to host a website, you would have to create a web server like this and actually generate the response, generate the page every single time someone came to your website. Right, so anytime someone comes to the site, this code is rerunning and it's regenerating this HTML. Right, we could even change this. Let's change our message. Let's make it a template string. And instead of saying hello world, let's say time, or the current time is date.now. And save that. And if you restart your server and go back to your page, to that home page, you'll see the current time is, and then the timestamp. And then if you refresh it, the timestamp is updated, right? Refresh it again, the timestamp is updated. This page is being regenerated every time someone visits our website. That's how websites used to work. Okay, but now we can generate all of this stuff on the front end, right? We can use React. We can generate all of this HTML with React. We no longer have to do this on the server side. So our web server, our API, can focus on just being an API. Right? Since our front end can generate all of that HTML for us, our back end can just focus on returning raw data instead of an actual page. All right, so we keep using this term API. the term API and web server aren't really synonymous. They're kind of different things, right? We've already defined a web server, which is just a piece of software that's meant to respond to incoming requests. But what is an API? Does anybody know what it stands for and what it actually means? What is an API? It's an application programming interface, right? That's what it stands for. It's essentially just a piece of software that makes a set of functions or endpoints publicly available to other code, right? That's what an API is. Remember when we were working with the DOM and we were working with the DOM API? All of those functions, like when we were in our DOM API, all of those functions that were made available to us, like we can call document.getElementById, right? That getElementById is available to us through the document API, right? It's a publicly available function. So within the context of a web server, an API is essentially just the endpoints that are being exposed to the internet for clients to manage different resources. Okay, it's like calling functions from endpoints. It's exposing these functions to specific endpoints. So this API specifically, we just have two resources, right? We have one resource that just returns our HTML body, and we have another resource that redirects. But it's not very useful if it returns HTML, because that's only applicable to browsers, right? If we were to go request this page from some other client that's not a browser, that HTML is going to be useless, right? So when we're building an API, we kind of want to deal with data and not websites. So we've already created two endpoints. Since we want this to be an API and not a website, we should return data in a format that's useful to these other apps. So what format should we return from our root endpoint instead of this HTML? What type of data should we be returning instead? JSON, right? We need to return some JSON data. Why should we return JSON data instead of HTML? What's the reasoning? Why is JSON data so useful? Why is it so cool? It's a standard, right? It's widely used. JSON data can be exchanged between any code, right? So you could have a C++ server that's running on some backend infrastructure, and it can exchange JSON data with your React app or an app that's running on someone's phone, right? You can exchange that JSON data over the network, and it provides a universal way for different services to talk to each other in an agreed upon language or format, right? So we can use JSON data to send data between any type of service. It's very extendable. So we've already used JSON a ton in the front end, right? We used it with our Redux state. We've used it to just manage state and to move it around to different components. But it turns out we can also use it in our backend, in our Node app, to manage data and even pass that data across the internet, right? Pass data from our backend to our front end. So let's change up this route handler to return JSON instead of HTML. Express makes it super easy. All we have to do is say res.json instead of res.send. We say res.json, we can now pass a JSON object instead of a string. Okay, and that JSON object can be whatever we want. Let's say message, and the message is going to be welcome to our API. Okay, normally if you were doing this without Express, you would have to go and set the header to the content type to application.json, and you'd have to convert your JSON object to a string. You have to stringify it and then send that to the client. But since this is Express, it just does all that for us. Okay, so if we say res.json and we pass this object, try saving that and then restarting your server. And go to that root URL again. And you see we now have JSON data that gets returned to us instead of HTML. So now our React app can call this endpoint. It can make an Axios call to this endpoint, and it can parse this body, and it can say like body.message and get our welcome message, right? We're now returning data in a format that's easy to read by any code. And that's the idea of an API, right? An API is something that can be consumed by any type of client, not just a browser. So let's see. Sarah, you asked, does it need to be double quotes or is single okay to use? Single quotes are okay to use in JavaScript. Yep. Just personal preference in this case. A lot of languages enforce double quotes instead of single quotes, but JavaScript, you can go either way. So someone asked, are URLs that we used during the front-end project to get data, are those APIs? What do you think? Are the URLs that we've used in our front-end applications to request data, are those URLs considered APIs? Yes, absolutely, because they're returning data in a global format, right? A reusable format. If it's returning data that can be consumed by something other than a browser, it's an API. So are web servers and APIs the same? If not, what's the difference? Okay, so hopefully we answered that question, whoever asked that. Yep. So web services and APIs are not necessarily, or web servers and APIs are not the same, because web servers can be anything that responds to an incoming request, right? It might return some JSON data, it might return some HTML, it might not even return anything. Maybe it just kicks off some kind of process, like sends an email or something, right? A web server can be, it can really be anything, but an API actually returns data, usually in the JSON format, some kind of reusable format. All right, any other questions before we move on? Make sure you update your poll. So Stephen, I would say kind of, an API runs on a web server, but a web server is not necessarily an API. We are not going to go over the difference between SOAP and REST. Nope, we're just going to cover REST. SOAP actually isn't used that much anymore. All right, so in the real world, in a real world application, our route handlers are going to do a lot more than just returning data, right? Than just GET requests. It's going to have to do things like query a database, write to a file system, make requests to external services, right? It needs to do a lot more than just return some flat data. So let's dive into this a little bit more to see how we can do some of that stuff inside of our request handlers. Let's actually fake a database. So we're just going to create a new file that just kind of fakes a database. Let's create a file and just call it database.js. And all this is going to do is return some data. So I have an object already written that we can use. Let me post it here. just going to return some data, really simple. 3 users, right? We have Jane Doe, John Doe, and Jack Doe. And then let's just import that file, that data, into our server.js. So let's const db equals require /database. Notice since we're importing an actual file in this case and not a module, we use the /. That signifies that this is a file that's right in the same folder as the current file. If we had left that out, then it would be looking for a module in Node modules or in the native Node modules called database, which we don't want. We want the actual file. So we'll put in a /. And let's create a new endpoint. We're going to say app.get again, only this time we're going to get /users. We're going to have the request and the response. And then let's just send back that database object, just all of our users. Let's say res.json db. Okay, save that, restart your server, and go to the URL /users. And you should see a list of our users. Cool. That's a simple endpoint, right? Not too much to that one. But let's create another route that gets a specific user based on its ID. Okay, this one will be a little bit more complicated. So do you remember in React Router when we used those things called route parameters, where you would put like a chunk of the URL, you would signify a chunk of the URL as like a piece of user information that would then get pulled into the props? We can actually do that same thing with Express, just by using the same syntax. So we can say app.get /users/:ID. So this is saying if you go to our API and you go to users/1, it should look up the user with the ID of 1, right? And Express makes that variable available to us through the request object. So we can say request.params.id, and it's going to get whatever value corresponds to that chunk of our URL. So let's look up our user from our database based on that ID. How should we do that? We want to say const user equals, how do we look up that user based on the ID? We're kind of faking the functionality of a database here, right? If this was an actual database, you'd have to go make a query to pull that data out of the database. But in our case, we already have the data. We just need to find it using a JavaScript function, right? So we can just do db.find. Good, Danny and Leslie. We can just say db.find, and it's going to take a callback, right? We can just compare the row.id, compare it to request.params.id. And that should find the user that corresponds with that ID that's coming from the URL. And then we can write a little conditional here. We can say if that user exists, if it actually returns something, then return that user to the browser or to the client. So we can just say res.json user. But here's where it gets interesting. If there is no user, let's say it didn't find that user, we have to return some kind of an error message to the browser, right? So we could just say like res.json and just pass through a message that says user not found, right? Or maybe error user not found. But what's something that we're missing on this array, in this response? What's something that we need to indicate to the browser that this is an actual error? We need a status code, right? So Express makes it easy to send status codes. All we have to do is say res.status. We can chain it together with the .json method. What's the status we should return for user not found? "404." Good. So now if someone goes to users/10, it's going to return a 404 and say no user exists with ID 10 because there's only 3 of them, right? Let's try it out. Restart your server. And go to users/1. Cool, users/1 returns our user with ID 1. But try going to users/5. Oh, we get our error message, user not found. If you look at the headers, you see we get a, actually, nope, that doesn't have the status code in it. I thought it would. If you look at the network request, you'll see we get a status of 404. So it's properly returning our error status and our error message if the user is not found. Cool. So now our users, the users of our API or the clients can request a list of users or one specific user. Okay, so what if we want to do something other than just reading data, right? Maybe we want to create data. Maybe we want to update data or delete data. So just like we would call .get and .post and .put with Axios, remember when we called all those methods with Axios? We can define our routes just that same way. We can say app.post to define a post request route, or app.put to define a put request route, so on and so forth. Okay, so let's implement a delete route. Let's say we wanted to delete one of our users from our database. We can do that just by defining a new route that's app.delete. Okay, and that means if an HTTP request comes through that has the method of delete for the route of users/some ID, then it's going to run this function. Okay, and then inside of this delete function, we're going to want to delete our user from the database, right? So let's first find our user. Let's say const user equals db.find, just the same thing that we did above. We can actually just copy it. So we copy that line from our get users ID. So we need to find the user before we delete it. We have to make sure it exists. And then we can actually copy the if statement too. We can say if the user exists, then do something. If it doesn't exist, then show a 404. But instead of just showing the user if it does exist, we want to actually delete it. So let's say db equals db.filter, right? We want to filter our database so that it doesn't include the user with that ID. So we can just say filter if the row ID is equal to the request.params.id. Then reassign it to database and then return the deleted user. Okay, this wouldn't be good practice since we're overriding this variable to do in production, right? We're working with mutable data right now. But this is just simulating a database, right? We're not trying to be super correct here. We're just trying to simulate the functionality of a database. So since we're overriding that variable, we're going to have to come up to the top and change const db. We're going to have to change that to a let db so that we can change that database value and remove that user. All right. So how do we test this? Obviously, we can't make a delete request from our browser, right? Our browser is good to test GET requests because you just go to the URL and it runs, but we can't actually make a delete request from our browser. So this is where these third-party tools come in handy. So let's take a 5-minute break. I'll let you catch up here, step away for a minute, and then we'll jump into Insomnia or Postman, whatever you're using when we get back. I'll see you in 5. I think I know what's causing that lifecycle error. Let me test it really quick and I'll see if that's the issue. I'll let you know. Okay, for those of you that are still here, if you're getting that E lifecycle error from Node, what the issue probably is your package.json is probably pointing to an index.js, which is the default for with package.json. But since we're using server.js, you want to change your package.json so it runs node server.js and not index.js. Okay, that could be a potential solution. Let me know if that works. Okay, come on back. Did that solve anybody's issue, that eat life cycle, or is that still a problem? Still a problem, huh? Let's see, I'm just reading through a Stack Overflow. Might have something to do with your Node installation. You could try running sudo npm start. So maybe if you tried running sudo npm start and then putting in your password, see if that fixes it. Sometimes when you install Node as the root user, it can cause problems. So you might just have to reinstall Node in that case. I would be surprised if that was it, though. All right, let's move on, and then we can mess with that at the end if we have time. It's expected to have issues like this when you first start out with Node, because everyone has different installations and different computers, different environments. So it'll take a while to sort all that stuff out, but hopefully we can get it all sorted out by next lecture so we can all be on the same page. Someone asked, why do you use the parameter name row in dbfind? I didn't hear why you used that. So why do we use row here? That's just whatever the parameter name is. You can name that anything you want. You can name it like user, you can name it A, V, you can name it whatever you want. I just name it row just because it makes sense, because we're kind of traversing a database. You kind of think of databases in terms of rows, but you can name that whatever you want. Let's see, just a little stupid question. Why is it required to restart our server each time we want to see the changes? Because when you start the server, Node is actually taking all this code and it's putting it into memory. So if you change it, it's not actually copying that change over to the instance that's in the memory. So you just have to restart the server in order to get those changes pulled. There is software out there that makes it easier, that will automatically restart your server when a file changes. And you're actually going to use that during the project. It's just called NodeMon. But we're not going to install it right now for the sake of time. All right, so let's take a look at Insomnia. If you want to go, you should have it installed already, or Postman, whichever one you prefer. Let me open it up real quick. So once you have it installed, go ahead and open it up. So we're really using these tools in terms of like manual testing, in terms of in terms of manual testing, using these tools is really the most practical way to test our applications, to test our APIs. There's a lot of different ways we could use to actually test our endpoints. We could like call it with our React app, right? That would test it. That's obviously not very practical. We could call like the curl command in our terminal to test our API endpoints. That'll also work, but that's very verbose and not very practical either. There's a lot of different tools out there. So it really just comes down to personal preference. If you prefer to use a tool like Insomnia, or maybe you don't even prefer to use a tool at all and you just want to do automated testing, that's another option, which we'll get into later. But in our case right now, just using one of these tools makes our lives a lot easier in order to just call our endpoints and send data and just test all that out manually. So let's open it up Insomnia and let's create a new request. Just on new request, we just call it welcome. Or let's try calling our welcome endpoint. So first start our server, npm start, and let's call that endpoint right there. So you can come up here to the browser or to the URL bar, type in our URL, our port. we're going to send a GET request and just hit send. And it returns our data in a nice format. Okay, and we can, this has a lot of flexibility because we can change the request method, right? We can set it to a post, put, patch, delete. We can send a request body if we want to send like some JSON or some XML or a multi-part form. We can set headers, right? If we maybe have an authentication token that we need to send. We can just basically test anything that we need to in this interface. So we can make a request to welcome. Let's create a new request and we'll call it users, right? Maybe we can get our list of users. Copy that URL so I don't have to retype it. Go to /users and get request to /users and it should get all of our users. Right? Maybe you go to users/1 and it should get our first user. Users/2 gets our second user. But the difference between this and a browser is we can make a delete request. So let's create a new request and we'll call it delete user. Right? We can try testing that delete functionality. We can copy that URL and let's try deleting our second user, our John Doe. So instead of get, this is going to be a delete request. And just hit send, delete users/2. And it says not found. Oh, because I didn't save the file. Let me save that file. And restart the server. And make that request. You see it returns our deleted user. Now if we go request our users list again, oh, we have a bug somewhere. It replaced all of our users with the deleted one. All right, let's see where that bug is. Yep, you're right. It should be not equals, not equals. Good catch. Thanks, Raymond. And since this is just all in memory, if you restart your server, that data should repopulate. So now if we get request on all of our users, we have all three. We can make our delete request to delete a user. Returns the deleted user. Now if we go request our users again, you'll see that user is gone. It is deleted. So this interface is super helpful for making these requests, right? You can save requests, you can save this out to a file and then send that file to someone and they can open it up and make all of these same requests. It's just a really nice, it's a really nice way to work when you're developing an API. Let's check out our redirect. Remember our redirect? Let's make a GET request to our endpoint /lambda. You'll see Insomnia actually redirects us to that endpoint. If you wanted to, you can actually open up the preferences and uncheck the one that says follow redirects. If you uncheck that and then make the request again, you'll see it doesn't actually redirect, it just returns the raw redirect response. So the body says found, redirecting to that. It's a 302 status. You'll see the header has a location with the redirect location. So it lets us debug that whole process as well. Cool. So if you're in Postman, this should be very similar. You might have like the buttons in different places or the layout might be a little bit different, but it's the same concept where we can call these endpoints from the software in it and we can send data and look at our response and so on and so forth. So as the last thing, let's implement a post request to create a user, okay? So right now we're listing users, we're deleting users. Let's add one that creates a new user with a post request. Yeah, Rose, if you're getting that constant variable issue, make sure you go to the top and you change const db to let db so that you can change that value. Okay, so let's create a new endpoint. So let's say app.post. So when a post request comes through /users, we're going to want to create a new user, right? So post request is a little bit different than the other requests that we've made so far, in that it requires a payload, right? It requires some kind of data to perform its operation. So when we make the post request from Insomnia, we actually have to send through some data, like we have to send through the user's name in order to create that new user. So in Express, if we want to actually get that value, we have to use something called middleware. Okay, we're all familiar with middleware from the Redux days. We're going to dive into it a lot more next week. But for now, all you need to do to install middleware that allows us to parse that response or that request body is we have to call app.use, and then we have to give it a value of express.json. All that's doing is it's using some middleware to parse the request body if it's JSON. The important thing to know right now is that when we use this app.use function, when we call that, it's essentially allowing us to, or allowing whatever function is getting passed, it's allowing it to access the request and the response for any of the routes, right? It's just kind of like a global catch-all for any of the routes. So it runs this before it runs any of these route handler functions. Okay, that's kind of the high level of Express middleware. But again, we're going to get to that next week. So just make sure you have this line so that we can get that request body. So now that we have that middleware, we can, inside of our post, we can call req request.body to get the response body, or the request body. Now that we can get that request body, let's say we require the request to include a body value of name, right? So when that request is called, the body should include a JSON object that has the value of name set to something, right? So let's create a new user object based on that value. We can say const new user, and we can say name. The name of this new user is going to be whatever value is in request.body.name. And then it needs an ID, right? So let's generate an ID. Let's just say ID is equal to the string value of whatever the database length is +1. So we're just incrementing that ID anytime a new user is created. All right, you're with me so far? So anything that's sent through as the body, if it's a JSON object, if the client says, this is a JSON object I'm sending to you, our Express app is going to decode that JSON object and give us access to it through that request.body value. Okay, we can access any of those JSON values. So now let's just create that user. Let's just say db.push. We're going to push that new user into the database. And then let's return the new user. So we'll say res.json, new user. And then what we can also do is we can set the status code. Since this is a creation operation and not just a get operation, we can return the status code of 201, if you remember that one, which signifies that the API created some kind of a resource, some kind of a new resource. And that's it. Okay, so now we have an endpoint that accepts a new user. So let's test it out. Let's go into Insomnia. And let's create a new request. And it's going to be create user. Let's copy our URL from welcome so we don't have to retype it. And it's going to be /users, but instead of a GET request, we're sending a POST request, right? And now this request is going to have a body. We need a JSON body. So if you're in Insomnia, you can click on body and then click on JSON to send some JSON data along with that request. And then we can now send a JSON object. So we can say name and then put your name in there. So this JSON object is going to get encoded and sent along with our HTTP request. And our server in turn is going to decode that object and give it to us in request.body. So go ahead and send that and see what happens. Quick tip, if you're in Insomnia, you can just type command enter or control enter. You can hit the control enter and it will run the request for you. Make sure you save your file. Make sure you restart your server. And run that. Cool. ID 4, name Jason Maurer. Go back to your user's request. And we now have a new user. Awesome. Let's run it again. Same request without restarting. Oh, we get ID 5 now. Jason Maurer, same name. Request our users and we have ID 5. Cool. So let's see. Let me look at my notes really quick. Last thing before we close here. It's important to note that these methods in our endpoints, like this push method and the find method, these are just simulating real database interactions, right? We're kind of just faking that whole interaction. If this was a real system, these would be actual database calls. And in your project tonight, you're actually going to be calling methods from another file that actually call a database, right? It's already set up for you. But you're going to actually be calling methods to write to the database and to read from the database and so on and so forth. But this right now, this is just simulating that whole interaction. We're not going to have time to do put requests today. I know that's on the assignment, so I think we can just consider that stretch, the put request on the assignment. But it's very, very similar to the post request, right? You just pull the data out of the body, and then you would update the user instead of creating a new one, right? So it's very similar, syntax at least. But the last thing I want to do before we close, one thing I did want to cover is data validation. Just some really, really simple data validation. For example, if I were to call this endpoint, let's say I call the create user endpoint, but I don't pass a name, let's say I just pass an empty object, it's still going to allow me to create a user without a name, right? Now if we go list our users, we're going to have one that is missing a name. We don't want that. Okay, we want to make sure in our backend when we're saving data, we want to make sure we're getting the data that we're expecting, that we ask for. So a very simple way to do that data check in our handler function is just by writing an if statement, right? We can just say if there's no name, so if request.body.name is a falsy value, then we can cancel the request and return an error. And the way that we cancel a request is we just return, right? We return something, and that prevents any of the code after this if statement from running. Kind of returns early from this handler function. And we can return res.status of 400, right? Because this is an error. And then just a JSON error that says need a username, right? So now if that username field is blank, it's going to throw an error and it's not going to actually create a user. which is what we want. So if we restart our server and try, we'll first list our users, reset our data, but now try creating a user without that name. And we get a 400 bad request, need a username. Cool. Try adding in our name and submitting again. And this time it let us through. 201 created. All right, that is it for tonight. Your first introduction to backend. I hope you enjoyed it. It's going to get a lot funner from here on out if you enjoy the technical aspect of these things. So buckle up. It's going to be a good time. Let me send you the link to our project. This is what you're going to be working on tonight. So like I said, it does require you to do a put request. Try and do it if you can. It's really similar to the post request. It should be, since you're just calling the database methods that are supplied to you, it should be really straightforward. But for the TLs that are here, let's consider that, the put requests, a stretch problem since we didn't cover it in the lecture. So try and do it if you can. And yeah, good luck, have fun with it. Good to see everyone again, and I'll see you on Thursday.